In this video, we're going to go ahead and go over a couple of the homework problems. I chose 3, 5, 6, and number 10. So in number 3, we're given g of x, and it's given as a quotient, so we need to simplify g of x before we take the derivative. The first step in my simplification is going to be to change this square root into the power of 1/2. And then I notice that I am dividing by this 3/2, so each term is going to be divided by 3/2. Now, when we divide powers with the same base, we subtract their exponents. So, in my first quotient, 2 minus 3/2 is going to be x to the 1/2. Second quotient, 1/2 minus 3/2 is going to give me a -1. And then x to the 3/2, if I bring that up, that's going to be a -3/2. I'm going to go ahead and apply the power rule now. So the derivative of g, notice how my notation changes. Power gets multiplied out in front, so 1/2 x to the -1/2. This negative power gets multiplied out in front, negative x. Again, because I'm powering down and there's already a negative, it becomes a -2. Multiply that 3/2 out in front, positive 3/2 x. I go ahead and power down by 1, and I get 1/2. So I'm going to clean up this derivative just a little bit. I'm going to go ahead and make those powers positive by rewriting them in this way. And then I think a step further, what I might do is change those 1/2 powers back into their square roots. So 1/2 times the square root of x minus 1/x squared plus 3 times the square root, or 3/2 times the square root of x. And I'm done. Okay, looking at number 5. Same idea. I need to go ahead and simplify f of t before I take the derivative of that. My first step in how I'm going to simplify this is I'm going to go ahead and distribute that t in the numerator. And so I get t cubed minus 5t all over t to the 1/3, which means actually each of those terms is being divided by t to the 1/3. So remember, the cube root is t to the 1/3 power. So I'm going to go ahead and do that. Dividing powers with the same base, you're going to go ahead and subtract their exponents. So 3 minus 1/3 is really 9/3 minus 1/3, which is 8/3. So t to the 8/3 power minus 5 to the t to the 2/3 power, because again, this has a power of 1. So 1 minus 1/3 is going to be 2/3. Now I can go ahead and apply the power rule. The derivative of f of t, 8/3 gets multiplied out in front. And then I'm going to go ahead and power down. Subtracting by 3/3 is the same thing as subtracting by 1. So 8 minus 3 is 5, so 5/3 minus. So 2/3 times 5 is going to be 10/3. I power down. So 2 minus 3 is going to be that -1/3. I'm going to clean up this derivative just a little bit, take care of that negative power. But really, I could be done in the previous step if I wanted to be. And there's your derivative. Let's go ahead and take a look at number 6. So number 6 should look somewhat familiar. That is a volume equation, but remember, any a, b, or c constant in our homework, any a, b, c variable or letter in our homework represents a constant. So that means that I am differentiating v. I'm differentiating v with respect to r, not b. I'm differentiating v with respect to r. And b is just my constant. So really, before I take this derivative, if I wanted to think about all of my coefficients kind of hanging out here in front, this is really 4/3 b pi times pi, like these are all constants, and I'm being multiplied by an r squared. So when I take the derivative of my v with respect to r, this 2 gets multiplied out in front, And so really 4/3 times 2 is 8/3. So 8/3 b pi r. Now, if that was a plus b, for example, if this was 4/3 pi r squared plus b, then the derivative of that constant would be 0. But because we have a product here of b, it just sort of groups in with the other coefficients and stays there when we take the derivative of it. Let's look at 10. Don't be nervous about 10 because now we see ln and e. Remember, ln and e, ln of e is equal to 1. So really, h of x is just ax, which means that when we go to take the derivative of h, if I have a power of 1 here, that gets multiplied out in front, and then I power down, so I'm left with just a.